In this module, we'll be taking a look at iTunes forensics. There's almost no doubt that most of us have a general familiarity of iTunes. We know that it's primarily used to organize a collection of your digital media files. And through the iTunes Store, you have the ability to purchase, rent, and download content such as movies, TV shows, music, books, and applications. You're also able to manage and share this digital content over your local network devices. So if you have laptops, desktops, an iPad, or an iPhone, you can share your digital library. You're able to subscribe to audio and video podcasts. There is also another feature that may not be well known. It's called Ping, and that's iTunes social network feature, and we'll be taking a look at that. You are also able to convert the audio and video formats to different formats, and with that functionality, burn CDs and DVDs. And finally, you're able to create backup and restore databases of your media files. Now, iTunes as a downloadable program has been around for about 11 and a half years. The first version, version 1.0, was released January 9th, 2001. And since that time, it has gone through a fair amount, or significant amount, of changes, and many or most of those changes are of significance to forensic examiners. The first of which happened in April 2003, that was version 4.0, and this is when the iTunes Store first went live. So for the first time, you were able to download a program onto your computer, use that program to go on to the iTunes Store, choose a file you wanted to legally download, and copy it to your machine. In October 2003, in version 4.1, this was a pretty significant update, and this is when the support for the Windows platforms on the iTunes program was essentially built into its design. So now forensic examiners had this entirely new media program that they had to consider when doing forensic examinations. In May 2005, version 4.8, this is where you see the video support being added for the iTunes program. So now you're able to download video files to the machine from the iTunes Store, also save it to your video library. So forensic examiners now had to consider this extra piece that was now built into the program. The release in June 2007, version 7.3, is what corresponded to the initial release of the iPhone. So iTunes was now compatible with this phone device that you could sync with iTunes for your video and your media content. Moving along to September 2009, that's where we see the functionality of home sharing being enabled on the iTunes library. So now, if you had an iPhone or different laptops or desktops, you were able to share this library across your local network. And finally, in March 2012, version 10.6, this is where we see the support for 1080p TV shows and movies. And why I included this in the slide is because as the content gets higher in terms of quality, the size of the files gets significantly larger. So as a forensic examiner, it may take longer to capture the image and to go through the data as we see higher levels of quality in terms of the media. Why should a forensic investigator analyze iTunes? What does a forensic investigator care about music files or downloaded content from the internet? And the answer is a lot. There certainly is a lot of information you can find based on a user's downloadable preferences, whether it's music files, video files, album artwork, images from these video files. And in most cases, forensic investigators are looking for digital contraband. So if they're downloading something illegally, maybe from a file share, and using that to infect other computers, they might say, oh, well, I never played that video file. Prove it. Well, with iTunes, you can go in, you can take a look at certain XML files and essentially go back to the prosecution and say, okay, well, here's what we have. We're able to prove that he downloaded this file on such and such a date, he played this file to completion on such and such a date, and he also played it approximately X number of times. And you're able to see that through the XML files for the iTunes library. And so that gets into what type of artifacts can be found. And what we'll be looking at are various registry settings based on the installation and files that are created for the uninstallation of iTunes. We'll be looking at log files that are created in the temporary directories when iTunes is installed. We will be looking at, again, the XML file, which is a database of all of the files that are in the iTunes library, and that includes music files, digital audiobooks, and videos. What we'll also be looking at is the ITL file, which is very similar to the XML file in terms of what it stores, and we can use that to essentially connect the iTunes library back to a particular user. And finally, we'll be looking at the artwork cache ITC2 files. And there's a lot of information that can be gathered here because with these files, you will have either the first frame of a video file. You will have the artwork of an album if they download an album from the iTunes store. You will also have book covers if they download a book from the iTunes store. And so we'll be getting into that. So the first thing we're going to take a look at is the log file that is created when iTunes is first installed. And this file is located, if you're on a Windows 7 machine, in the users directory, then slash the username, app data, local, temp, and you will see a log file, iTunes 64 if it's a 64-bit system, or just iTunes setup.log. So opening up the file, there's a couple of things that we can determine based on the installation of the program. And the first thing that we'll take a look at is the product to install. And with all programs, the product to install will be assigned a specific GUID. We've seen this before in other modules, such as the USB module, where you would plug in a USB device and it would be assigned a specific GUID. The same scenario when a program is installed, they are also assigned a specific GUID. The second thing we'll take a look at is the information on cabinet file. This is where the file itself was downloaded. So when you went on to iTunes.com, you clicked on save, you saved it to the computer. In this case, it went to cusers demo /downloads /iTunes setup 1.exe. And if you take a look at the bottom of the file, the very last line in the log, so the log is a little bit bigger than what the screen is able to show, but I did copy and paste the final line of the log, and you'll see executing the installation file itself. So when a file installs, it unpacks the files needed to install the program into a temporary directory. And so we can see the temporary directory where the temp files were kept during the duration of the installation of iTunes. And that is in C users demo app data local temp. So we can confirm that the file was in fact downloaded to the machine and installed on the machine. So now let's take a look at the registry keys that are created when iTunes is installed. The first thing we'll take a look at is the location in the registry. We'll look at the uninstaller keys first, and there's a reason for that. And so they're located HKey local machine /software /Microsoft, then Windows, current version, uninstall, and then again you'll see the 16-byte product ID, the same as we saw in the log file. And again, that's the ID starting 840A3BAA. And you'll notice it on the bottom left of the screen. It is selected, and once we select that key, we're able to see all of the relevant installation keys that are installation values that are created with the installation of iTunes. And I want to just jump ahead for a moment and explain that the GUID that you see here at the top, it's not random. It certainly can be randomly generated, but most programs do follow a particular algorithm. And just to show you, I have the Microsoft Office 2003 GUID algorithm listed here, and you'll notice that the first character is the release version, the next character is the release type, and then followed by the major and minor versions. iTunes most likely follows a similar format. It is most likely possible that it is just not public. They don't provide that to the public to see what algorithm they use in designing those GUIDs, but it's most likely similar to what you see here. And these are read in big endian format. You'll notice that the 16 bytes are broken out in 5 sections, the first being 4 bytes, and then 2, 2, 2, and finally 6 bytes. And the sections are important. So with the big endian, the 8-4, the 4C, the 4-5, the 9C, and the 6F are the most significant digits of each section, and we'll explain the significance of that when we look at the installer registry keys. Moving back to the registry keys, let's take a look at some of those values that are created. And some things to note are the display version. That's the version of iTunes that's currently installed. In this case, it's 10.6.3.25. This is a value that changes as iTunes is updated. So if we were to install a newer version of iTunes, this value would change to whatever the newest version is. We also see the installation date, which was 7/7/2012. That was also the date it was last updated, not the date it was originally installed. And this is a string value, so with all string values, you could actually go in here and physically change it. You could change it to any date that you wanted, and it would stick even with the reboot of the machine. And moving on to the installer registry keys that are created when iTunes is installed. These are located in HKey local machine, software, Microsoft, Windows, current version, installer, user data, and then the system profile because it's installed for all users, and then products, and then again it's the 16-byte GUID, and you can see that on the left hand side, but it is a little bit different. The characters are exactly the same, and what this is, it's called a squished GUID. So I did put both values at the top, the original product ID and the squished GUID at the bottom. You will notice that all the characters are the same, they're just arranged slightly different, and it's the computer's internal, it's another way the computer internally represents that product ID. Now looking at some of the values, you'll notice that the values for the installer registry keys are almost exactly the same as the uninstaller registry keys, except for one minor difference, and that is halfway down on the right hand side you will see local package, and this is the MSI, the internal installer utility installing the program for iTunes. Now let's examine the iTunes XML and ITL files. And these two files are very similar, and what they are is a dynamic database of the media in the iTunes library. They include things such as the track names, they include the titles, they include the artists, they include any song ratings or user customizable information such as comments that may be added to the files themselves. And we can find these, they're easy to find, they're not hidden. They are in if you're using a Mac, the users/username/music/iTunes, or XP documents and settings/username/mymusic, and then iTunes. And this is a Windows 7 machine, so we'll be looking at the users folder and then the name of the user My Music, and iTunes. First, we'll take a look at the iTunes Music Library XML in Winhex. And the first thing we'll notice is it has a standard XML header, and that's 3C, 3F, 78. And we could actually keep going with the XML header. There's a really good file signatures table that was created by Gary Kessler, and I'll have that link for you at the end of the lesson. Check that out when you get a chance, because that has an incredible amount of file signatures and different file extensions that you can use in your carving and your own forensic examinations in the future. And now what we're mainly concerned with here is, if you look on the bottom right at the library persistent ID, what that is, it's specific ID for this particular iTunes library. Each iTunes library has its own library persistent ID, and if you look, we're going to see it in many different areas. And if you're looking at the XML file in hex view, it's not in any particular offset, but you can certainly search for it. It is an ASCII value, and again, we're going to be seeing this pop up in many different areas of our forensic analysis of iTunes. Moving along to the XML file, this is just your standard XML file. You can open it up in any Word, Notepad, HTML type of browser or program, and you can clearly read all of the information in the file. And it has track information or video information, such as the track ID, which is a unique identifier for that particular MP3 file or video file. You will see the name of the track. So in this case, it's a briefer history of time, 1-01. We can see the type of file that it is, and in this case it's an MPEG audio file. The size, which is about 320 kilobytes. The length of the file, the year that it was created, although this isn't really a timestamp hexadecimal type of creation. This is something that goes along with the title. Looking at the date modified, what we see here is 2007-0303, 1952. What this is, this file in particular was not downloaded from the iTunes store. Date modified is an MP3 scenario. Typically can be the time that it was ripped from whatever CD that it came from. And below this you'll see the date added on the left hand side, and this is the date that the file was added to the iTunes library. So moving along, you just have your standard additional information about the track, the bit rate, the sample rate, and comments. They can be created by the user, meaning you, or these can be created by whoever created the MP3 file. Now, it's interesting to note that up till this point, and this is still considering the left-hand side of the screen, I hadn't played this file yet in my iTunes library. And you can see on the left-hand side, under the comments, you see read by Eric Davies, and right underneath that, you'll see sort album, and then brief history of time, meaning it's going into that particular album. And now, on 7/8/2012, at about 5:19 Eastern Time, or 21:19 UTC, I opened up this file in iTunes. I played it from beginning to end, and after that was completed, I went back into the XML file and went down to the same record, key 2458. I found my brief history of time 1-01 file, and here we see some new values have been added. And now we're moving along to the right-hand side of the screen. Underneath that comments field, we now have a play count. And we have a play count that shows 1. And we have a play date in hexadecimal, which shows us the exact date that it was played in UTC format, which was 7/8/2012 at 21:19 UTC. And what's interesting to note is keep in mind that this was only updated after I played the file completely from beginning to end. So if I've only played half of the file and then stopped it, we wouldn't have a play count here. We wouldn't have a play date. We wouldn't have a play date UTC. So again, I'd like you to take a look at down here on the bottom right, and that is the persistent ID. And this is an ID that is specific to this track. So each MP3, each video file, each audio book has its own persistent ID, and that will come up in our analysis as we delve further into iTunes. The next file we'll be looking at is the iTunes ITL file. It is located in the same directory as the XML file we were reviewing earlier, and when you look at it in Winhex, it does have a standard header. It is 68, 64, 66, 6D, and in ASCII it is HDF as in Frank and then M. And this file in particular contains much of the same information as the XML file, except that there is no public binary file format, so it's not released to the outside. There's no definitive resource to look at it and determine which offset means what. So that would be done through reverse engineering, or maybe knowing someone at Apple that can provide that information to you. And a couple of pieces of information you can see in the iTunes ITL file. One is the information about the version number, and that is at offset starting 17 and moving over to offset 22. And secondly, even more importantly, is the library persistent user ID, and that is what we've seen before in the XML file, and that is located at offset 52, and it moves over to offset 59, and that is a value F5CA 83 FA 81 F5 1C 7F. And just moving back quickly, taking a look at the iTunes XML file, we want to confirm that the library persistent IDs are the same across both files. And if we take a look at the very bottom right in the highlighted characters here, we can see the persistent ID in ASCII form. So the hex values you see on the screen are the hex values, but the text is in ASCII. And when we go back to the ITL file, it's just the straight hex. I mean, we have that library persistent ID in the middle of the screen, and it's the values that we've been seeing: F5, CA, 83, FA, etc. So now let's move on to the artwork cache file, and this is where we're going to find a wealth of information. And so what the artwork cache file is iTunes stores ITC2 image cache files for albums, videos, and book covers. And they're similar to the thumbsdb files that we've looked at in the past. And these .itc2 files, they include album artwork, they include book covers if you download audiobooks. They are also, if you have video files, the very first frame of the video file. It's a great forensic remnant to find contraband movies, video files that may have been deleted, or they may have been viewed as cover flows and then removed from the library. The only downside to these files is that they do not capture date and time stamps. We can determine that they are created when in iTunes you look at either the grid view or the cover flow, which are the rightmost boxes on the top right of the screen, and this is a picture that I took from iTunes. The files, they're not hidden. They are located, if you're on a Windows 7 machine, the users directory / the username, and then /music, iTunes, album artwork, cache, and then / the GUID for the library name. So it's that ID that we've been seeing in the ITL files and also the XML files. And then 3 more directories below. And there is a format, there is a reasoning behind how these 3 subdirectories are created, and it's actually based on the ITC file itself. What it does is it looks at the last 3 characters of the ITC file name, which is based on the persistent ID, and it creates three separate folders based on the last three characters. So here we have subfolders 000006. And when we look at the last three characters, we see 0, 0, and 6. So it's done in reverse. So with 6 is 06, 0 is 00, and 0 is again 00. So that's the naming convention for the subfiles below that cache folder and the GUID library folder name. So anyway, once we get down to that lowest subfolder, in this case it's 06, we actually see the ITC2 file name. And all of these ITC2 file names follow the same type of naming convention, and they're two hexadecimal 8-byte values. The first section is the GUID, and that's followed by a dash, and that is followed by the persistent ID of the track. And every track, every video file, every book has its own persistent ID. That's what we've seen before, and every single ITC2 file will have a naming convention that follows this format. So again, it's the GUID dash the persistent ID of the track. And so let's move on to looking at the file in Winhex. And all .itc2 files have their own standard header. It's 00, 00, 01, 1C, 69, 74, 63, 68. So you could search system for this hex value, find any deleted ITC2 files. Looking at the file itself in offset 4 through 7, we can see that in ASCII it reads ITCH, which most likely stands for ITC header, but you could certainly search for that instance as well. And moving down at offsets 312 and 319 in decimal, you will see a reference which is highlighted on the screen to the iTunes library GUID, which is also the parent directory 3 levels up from where we are now. And following along, directly after the library GUID, we'll see the persistent ID of this track. So again, there's an ITC2 file for every single cached album artwork or video file. And in offsets 320 to 327, we'll see that track persistent ID. Directly underneath the library GUID, there's another important piece of information at offsets 328 to 331, and you'll see them on the right hand side of the screen in ASCII text. It says LOCL, and what this is telling us is that the file was local to the machine. It was not downloaded. The other option that it could be is DOWN, and right now we have the value 6C, 6F, 62, and then 6C. So some of you might be thinking, well, okay, this is all great, but now how do I actually see the picture? I want to know what it is. Why can't I just change the extension? So essentially look at the ITC2 file, right-click, view, choose a program, select the Windows picture viewer or Paint or another kind of viewing program. Well, it's not going to work like that. But what you can do is carve out a certain from a certain offset to a certain offset, and you can see that artwork file. So it may not be viewable in the folder, but by selecting from the offset 492, which if you look at the very bottom of the screen, it is right before the capital PNG, so right on that block at offset 492, and selecting from that range all the way down to the end of the file, we can copy that block to a new file. And now that we copy the block into a new file, we will save it as a .png. And referring back to the previous slide, just looking at that offset 492, right after that we did see a capital PNG. that should show you what to save the file as. And once you save it, we can navigate over to the folder and we can see the picture. So in this case, it was the first frame of a video file. It may not be very clear in the image, but it's a picture outside of the Luxor Hotel. And so now you can go through your own machines and open up those ITC2 files, carve at that same offset from 492 all the way to the bottom. Every file is a different size. That starting offset 492 will always be 492, so just keep in mind you're going to go all the way to the end. So just go all the way to the end of the file, and once you save it as a .png, and you'll be able to view that file or all those files on your machines. And at this point, you should have a pretty good understanding of how to forensically analyze iTunes, looking at the XML file, being able to parse the ITL file, and also being able to carve out those ITC2 artwork files. Hopefully be able to go back to your own iTunes programs and use this in your real-world forensic experience. So now if you see this on the job or wherever you may go, you'll have a basic familiarity of iTunes, how it works, and how those files are created. A couple final thoughts that I came up with while doing my research. One of the big ones was, how do the network libraries play into an investigation? I know that after the update in 2009 that allowed home sharing, you could view other libraries that were on your local network. And what this means, why this is significant, is because being able to access the suspect's library from other machines, it actually does modify the play count. So if you were to play a file to completion using a remote machine, that would actually change the play count on the host library. So that's something that is forensically important. Also, if you're doing a live acquisition and you notice that there are other libraries, other computers, you just want to make sure that you note that if the device happens to not be listed on the search warrant, you want to make sure to keep a record of that, and that we can go back and you'll have that information. The second thing I wanted to tell you also is the file signature template, the file signature guide by Gary Kessler. The link is available here. It's garykessler.net/library/file_sigs.html. You'll be able to use that a lot. There's so many file signatures, and you can search this whole website for many of them, and I hope that it helps you. And finally, I know that I mentioned iTunes ping at the very beginning of the lesson here, and I did want to explain what it is and what it does. I wasn't familiar with it. I had never heard of it before starting this project. And what it is a social media, it's a cross between Facebook and Twitter for iTunes. And if you have a ping account set up, you're able to quote unquote share your library online with other users. You can follow artists, you can follow friends, you can see songs that they have or albums that they have liked, and you can listen to 30-second snippets of each one of those songs. And I just wanted to let you know, I know that a couple of individuals have done social media investigations in the past, Facebook and Twitter, and just not to leave this one out if you don't know about it. So it certainly can give you a good guide of the suspect's information, their music, other comments they have made to other people potentially, and also possibly other comments people have made to them. So just not to skip over that if you're not familiar with it. I hope that this iTunes ping account information helps as well. So finally, that's it. Any questions, feel free to use the board or message me. I'd be glad to help you any way I can. Thank you very much, and I hope you'll be able to use this in your professional forensic experience.